Hey, this is Bradley Bush. Today we're going to talk about another classic topic in algebra, which is long division of polynomials. There's something special about this specific problem. It is missing a term. What I mean is, in the numerator here we have a cubed term, and the next term down has a power of 1. So we can see that there is no x squared term. So that makes this a little bit unique. All we do is end up adding a placeholder, and that's it. The rest of it just follows the same pattern as a standard long division problem. So let's rewrite this as a long division problem. So again, we put the denominator out front, and we put the numerator underneath the division symbol. I like to have lines dividing each of my columns, meaning this column is the x cubed column, this column is the x squared column, this is the x to the first power column, this is the constant column. And that just helps me organize it, but you don't necessarily have to have those. So let's start. We start by saying we want 3x to become 9x cubed. So for 3x to become 9x cubed, we have to multiply by 3x squared. So we're going to put the 3x squared in. And notice here, the only reason I have a column for the x squared is because I plugged in a space holder for the missing term. So notice that wasn't in the original. I didn't have an x squared term up here, but I put in 0 times x squared, which is just 0, but I put in a placeholder so that there would be a space to have x squareds through the problem solution. Because as we go along, we're going to have x squared terms pop up and we need a place for them. So make sure that you put that placeholder in. So 3x squared multiplied by 3x minus 4 gives us 9x cubed minus 12x squared, which we put here below the 9x cubed plus 0x squared. 9x cubed minus 12x squared. We change our signs and add, or in other words, if you want to say we subtract, that's fine also. 0, 12x squared. Now we pull down the next line and we ask ourselves, can we stop? Are we done? We can't stop until the exponent at our current step, the highest exponent at our current step, is 1 smaller than the exponent out in front. So down here we have a 2 as an exponent, and our highest exponent out in front is a 1, so we can't stop yet. So let's keep going. Now we want to have 3x become 12x squared. So to have 3x become 12x squared, we need to multiply by 4x. So we're going to put a 4x up here. 4x times 3x minus 4 gives us 12x squared minus 16x, which we'll place up here underneath the 12x squared minus x. Again, we change the signs and we add. I will circle the signs once I change them, just so I know that I've changed them. 0 here, and we get positive 15x here. We can pull down a positive 1. And again, we check, can we stop? My highest exponent here is a 1. here it's a 1, so they're the same. We got to keep going. The next time, after the next round will probably be our stopping point. So currently now we want our 3x to become 15x. So for our 3x to become 15x, we need to multiply by 5. So we'll put a 5 up here. 5 times 3x minus 4. That's a terrible 3x. Let me do that again. Gives us 15x minus 20, which we put down here, 15x minus 20. We change these signs, and then we add, and we get 21. We can stop here because the exponent here is 1 less than it is up in front. What I mean is the exponent here, you could think of it as x to the 0, just because x to the 0 is 1, and 0 is 1 less than 1, so we're good. So we can actually delete that x to the 0. So 21 is our remainder. And it goes up top. And we always put it over whatever is out front here. So to summarize, 9x cubed minus x plus 1 divided by 3x minus 4 is 3x squared plus 4x plus 5 plus 21 divided by 3x minus 4. That's it. Thanks.